Okay, today we're going to explain something about the construction of these kind of buildings. With the mass timber structure, well, we have created the structural elements, the columns, trusses. Well, we started creating foundations with concrete. Foundations are always made of concrete. And then this is a mass timber or laminated glue structure or glued laminated wood. Anyway, it's made of wood, but it's not the framing. Okay, so we have the timber frame or the balloon frame. This is the traditional American style, especially for residential buildings. Okay, so we have this balloon frame, we have these frames, and then we have rafters, we have main structural elements, but then we have rafters, and then we have these openings. Okay, so this is how or what construction looked like 200 years ago. We can still find examples of this kind of construction, especially if we are refurbishing this kind of these buildings. But mass timber, it's something different. Okay, so with mass timber, probably we're using structural elements like this. So those are the wood columns. This is a concrete. I don't know if this is the foundation or is the ground floor or the first floor. Anyway, after the first floor, we start with this kind of structure, and then as you can see, we place prefabricated panels on site. This is very convenient because with a prefabricated panel, the likelihood of having a bad construction is less than building things on site. So usually we fabricate these panels in a workshop, and then we place the panel with a crane. We place the panels, but as you can see, we have the thermal insulation, the finish, the window, the operable window. So everything is on the same panel, and then we place it on site just by connecting this panel to these elements here. Okay? So this is a more reliable construction, and it's becoming mainstream now. So little by little, we are leaving the balloon frame or the frame construction, and we are working with this kind, even in residential buildings. This looks like a residential building. And we are using with this kind of wooden structures and this kind of prefabricated panels. This is what we are going to do in this project. Okay, the wall. Imagine that the wall that we are using is made of this kind of panels like this, and the structure that you have been designing. For sure, we have these laminated wood columns. So here, this is the typical detail of the frame construction, not the mass timber construction. So here we have the rafters. We have these elements here are the structural elements, rafters. The distance between two rafters usually is 16 inches. And then we fill the space between rafters with thermal insulation. Then we have another layer of thermal insulation here to solve the thermal breach, because if we don't have any thermal insulation, the rafter is a thermal breach itself. So we place another layer of thermal insulation here, and then we have these buttons. Well, this is something to hold the tiles, the roof tiles. These roof tiles can be either ceramic or natural stone or asphalt, shingles, or whatever. Usually when we are using natural stone, we have these buttons because we need to hold the weight of these tiles. We are not going to do this. We are going to work with panels like this. Okay, so you see that in this panel, everything is, we have the indoor sheeting, the outdoor, and then we have the thermal insulation. This is rigid insulation, this blue stuff, it's polystyrene. We have this rigid insulation inside. If we want to go sustainable, we can do this, what we have on the left side of the screen. Well, it's cool. So here you see how this guy is using straw bales on a roof, on a tilted roof. So he's creating like these boxes, and then he's filling that space. Instead of filling it with rigid insulation or even with cellulose, we are doing this with straw bales. Interesting. Well, it's interesting because, hello. Oh,
I'm listening.
okay. This is interesting. I mean, using straw bales as an insulation material. Well, because it has a very low embedded energy and a very low carbon emissions. I mean, because this is straw bale, so it doesn't take any energy to manufacture this material. Unlike the rigid insulation, which is something that takes a lot of energy and it emits a lot of CO2 to the atmosphere in the manufacturing process. What's the disadvantage of this? That probably the thermal insulation that we can get with 3 inches of rigid insulation, we need 10 or 12 inches of straw bale to get the same thermal insulation. Do you like it or?
Yeah, at one point in my life, I detailed, or we designed and then was around for detailing a straw bale house. It's really difficult.
It's really difficult.
To do it well, it's really difficult.
This is what I think, and I don't know, is it reliable? Who knows? Anyway, but there's an option. So if we want to go sustainable,
Sorry.
we can do it. Sometimes we tend to think that the future will be some place in which technology is everywhere and everything is connected to the internet, but future might be this. We don't know. Anyway, there's an option, especially here in the Northeast, or there's a tradition of using these kind of materials even for walls. So don't think that this is not going to happen, because maybe in 50 years, all the roofs will be like this one. I don't know. Anyway, I'm showing you both. Well, there are 3 options. We have this option with traditional rafters. These straw bales is the same option here with rafters and thermal insulation in the middle. But using straw bale instead of cellulose or instead of any other fiberglass or rigid insulation, whatever. But this is the most advanced option that we can get in this. So we have the structural elements, and then we have these panels, and those panels are sandwich panels because we have an internal finish and external finish, and we have a core of rigid insulation inside. Again, I think I've told you before, when I was a student, they told me that this is the best thing we could do. So when I came to the Northeast and I saw that there are a lot of people doing this, I said, what? Okay, that maybe this is the future and this is the past. We don't know. Anyway, we're going to use this option. We're going to use panels. I remember that you have already you have submitted something like that. This is a panel. Instead of having a wood finish, we have this zinc, because, well, zinc, it's more reliable, it needs waterproof. So we have this detail here, but this is the rigid insulation, number 3, yep. We have a finish, this is number 5, this is plywood, whatever. And this is the zinc here, covering this to provide waterproof and so that the rigid insulation is not affected by water. We are going to do the same now. We're going to create like a sheet like this with the detail, 2D detail, 3D details, with all the text here, the captions, to understand what these numbers stand for. We are going to do the same with the wall. Okay, so we have this wall here, this roof, sorry. And today we are going to work with walls. Okay, so we are going to work with something like that. Our wall, it's going to be a prefabricated panel, something like that. And for sure, this panel, we will have this stats or structural elements, the rigid, the thermal insulation, and then the finish. We can work with windows here, but we have to prepare this document with the wall. So there will be a detail, black and white detail, and then we will have a 3D detail with colors, trying to work with different layers. This is what we're going to do now. And the final aspect is going to be something like this. And what is this? Well, we have materials here. One is inside gypsum wall, board. Then we have inside insulation, or no, I think the 6 is the gypsum board, 5 is the inside insulation. This is the pattern. It's a small structure, secondary structure. So this is the main structure, and this is the pattern. Then we have vapor barriers, mainframe insulation. The mainframe is this one. The number, the mainframe is, so the thickness, this thick insulation here. And then we have the wind protection and the final finish material. Okay, so this is the detail that we are going to create now. You can work with numbers, and then you have this legend here. But we do have other examples, and other examples are here. So if we look at this, oh, it's the same. So this one is the same. And okay, we have this one. This is an actual company. They manufacture this prefabricated. They are using steel frames. They are not using a wood structure. Okay, so we can do exactly the same, but with a steel frame instead of with a wood frame instead of a steel frame here. So if you open this, you view details. Okay, so here we have the layers and the materials. So this is what we're going to do. This is too much, I think, but yeah, we have a finish. Yeah, we have a lot of layers, vapor barriers, air barriers. Air tightness is important in this kind of construction, of this prefabricated construction. We have rigid insulation. We have here we have the steel frame, and well, we are not going to work with steel frames, but this is another option that you can look at. But what I want to show you today is this. We're going to go local, and we are going to work with Benson Wood. Benson Wood is, well, it's an outstanding company, and it's in Keene, New Hampshire, so it's perfect. It's a few blocks away from Keene State College. And they create these prefabricated panels on site, okay? And so this is it. It's very simple. We have a frame. Then they fill this frame with cellulose. They work with cellulose. And then they place the panels on site like this. So, and they have these details, and those details are available for architects. And they take care of the roof, the wall panels, the windows, so everything is prefabricated, and you only have to place it on site. And it's quite good, efficient. It's cheaper because you don't have to work on site. Everything is done. You only have to assemble things, but everything's done in the workshop. As always, we have the concrete foundation, and then at the top of the concrete foundation, we can start with this wooden structure. Those are examples. And I have contacted these guys from Benson Wood, and they have sent me. No, it's on campus. They have sent me these Revit templates, interesting, and they have sent me their catalog. This is the tectonics. So they have this branch of Benson Wood, is tectonics, and it's the part of the company that manufactures this kind of prefabricated. So I'm going to open this. Okay, they have these three different kinds. We can have a vented facade or a vented roof or unvented facade and roof. And this is always, well, it's not controversial. We can have vented or unvented roofs. The good thing is that they specify this R50 roof. Well, R50 is quite good if we want more, or R55. Okay, so they, by default, they specify these R50 or R55 roofs and walls. So it's very close to the passive house standards, so it's quite good. And yeah, so this is what we're going to do, and this is what they have. So here they have details, different elements, and here you have another legend that you can copy and paste. Okay, so basically we're going to work with something like that. You can use numbers or A, B, C, D, and then you can copy all these legend here. What is it? So A is the interior finish. So this is interior, and this is exterior. And here we have R26, R36, R53 or plus. So we are going to use this one for the walls. D is structural framing and insulation. And they use dense packed cellulose. Okay, so they use insulation between rafters. So this is where the rafters are. And between two rafters, we have this cellulose insulation. And then we have this B, which is the, okay. So this is run mechanical and structural connections. Okay, so in this is interior. And here in this chamber, we can use wires or pipes. Okay, so that the main thermal insulation is not affected. And then we can cover this with extra insulation, with extra additional insulation, and then we can increase the R value. Okay, so that's why here we have R50 plus, because if we add this layer of thermal insulation here, we increase the R value. And here you have the thicknesses. Okay, so we have 11 1/4 inches of cellulose here. Then E is the weather resistant barrier. And then we have the rain screen and exterior cladding, custom. So you can do whatever you feel like here. You can use plywood or whatever. Okay, so we're going to use this detail, the R53 plus. We can copy this legend. Okay, and finally, we need a detail like this. We don't need this material. Okay, if we are working with ABC, here we need A, B, C, D, whatever. Or if we are working with numbers, here we need 1, 2, 3, 4, 5, 6. But this is the thing that you have to submit using the same format that you use for this one. If this is a vertical one with this frame, you have to do the same thing. You have to create this detail and that detail in Revit, and then you have to prepare like a document like this one. The good thing is that we have the Revit families. Okay, so if you open the Revit family, here there is a catalog of this. I expected that we could have just, we can upload this on our Revit file. Unfortunately, we can't. But at least if you get rid of the letters that are 3D, by the way, so we can use, I don't know which one we can use, this one, the 2 by 10 stats. So that means that in this layer of cellulose, we will have 2 by 10 stats here, and the distance will be 16 inches. But imagine that we work with this one, we copy this one, where in a different file. And we place it here. Now this is a 3D. And on that file, I can work with parts. And now I have all the parts here. So you don't have to do it from scratch. So you just can upload this, and now you have to, you can create like different layers. You can show different layers like we have here. Okay. And then if you take a section of this wall, if you fix the levels and all that stuff, but you can work with annotate. You can create here the thermal insulation and the hatches for different layers. Okay. And you can create, well, you can work with parts as well. So using this Benson wood detail, you can do this easily. The only thing you have to insert the rafters. Okay, so somewhere we can work with level 1. And on level 1, we know that in this layer, that would be the cellulose. So here we can work with component model in place, not mechanical, textural. We can work with walls. And we can work with extrusion. And with that extrusion, we have the rafter. It's a 2-inch rafter like this. And now the 3D. Yeah. So that would be the rafter, and then we need to copy. And we have to move it 16 inches is 1 foot and 4 inches. And now copy. Okay, so now you can work with this. Show handles. Yep. So we will end up having the same thing we have here. Okay. You can copy the legend is from Benson wood, the detail is from Benson wood. The only thing is that you need 1, 2, 3, 4, 5, 6, 7. One of these materials are just like thin films, so probably it's not, it doesn't have a thickness. It's just a film or a membrane. So probably you won't find the 6 materials, but most of them are here. So you can place numbers, and then you can place legend, and then you can prepare this document. And now we will have a roof, the roof that we are going to use, and we will have the wall that we are going to use, and we are sure that this wall is R53, so it's quite good. So this is what you have to do today using the Benson wood detail, and then you have to add colors. I'm not going to do that, you know how to do it. And you have to use the same color code that you used for the roof. So if you have used the yellow color for the thermal insulation, you would need a yellow color, the same yellow color, the same color that you have used for the wood. It has to be here and whatever. But you can work with this, and we need a section, and we need a 3D view, and we need a list of materials that this wall is made of. Next week, we will work with this detail, okay? Because the goal is to create like a section like this from the foundations up to the roof. And there will be windows here. And details for windows are complicated. So this is a window, it's made of wood. And as you can see, we have a triple glazing, so it's a good detail. And even these wooden elements, you see that it's made of, we have these shapes, and all these shapes and all these elements have their meaning. So we are not designing this kind of details. We have to copy these details, but designing windows, it's quite complicated because airtightness is something very important. And we have this rubber here, this is the blue stuff here, but this is not blue, this is like, well, it's the same color. But that makes the window tight. Okay, so we have a double air barrier here, so that when we close the window, we are preventing the air from entering this. And we have the first barrier here, then we have a cavity, and then we have another barrier here, so that we don't have airflow getting into the building. And here we have another, this is the third barrier, which is this element. And usually we combine wood and aluminum, because aluminum is more reliable than wood, especially if it's outside. So this element is outside, and we have to get rid of water here. So that's why this piece or this element is made of aluminum. Anyway, designing windows is complicated. We don't have to do that, but we need to understand what a window looks like, because eventually we have to connect our wall to the windows here. And there are a lot of elements, okay, between this, which is the window itself, the frame, the openable frame, and the openable window in the frame itself. This is the wall. So between the window and the wall, there are a lot of tiny elements that we need to understand. Okay, we will do this next week, so that when we have a section, we see this wall to roof transition, but then we will zoom in here, and there will be a call out here and there at the top of the window and at the bottom of the window. And then we will have to analyze, this is the top and this is the bottom of the window. We will have to analyze these details in that wall. Okay. In the end, architecture is about connecting things. We have a wall, we have a roof, we have to connect the wall and the roof. And this is what architecture is, because we are not manufacturing the wall. The wall is already done in the workshop. And we are not designing the window. So there's a window, and we have to take that window or to copy that window. And we don't have to design the roof. So there are roofs, there are roof panels. But putting everything together, this is what architecture is about. So this is what we're going to do over the last two weeks. We are analyzing different elements, but now we have to assemble everything together, and we have to create a section from the footing until the roof of the building. Okay, so by next week, I want you to do this. And at the same time, I want you to keep on working on the okay, so you have to keep on working on this building. And today, now I'm going to talk about modeling things. So it's not about construction. We will model and we will create the skylight and all that stuff. Okay, as I told you, I have just extended that wall. So if you remember last week, we created this, my wall 2 edit type. And what is this? Okay, so this is softwood. We have 7 inches of rigid insulation, and then we have softwood here. I would appreciate that you create the new wall that you're working with. Okay, so if you're working with this kind of wall, and the benson wood thermal insulation is 10 inches, and then we have 2 inches, 2 extra inches to avoid the thermal breach. Okay, you can do that. Anyway, I'm not going to do it, but I'll check what kind of walls you are working with. Okay, that's fine, but it can be better. And now we have to insert windows. Well, if we look at the original file, because we inserted a few windows here. Okay, so we have a window here, and we have windows at the front of the building. I think there are 2 different windows. So let's open the yeah, I think those windows are getting to the top of this of the wall. So they are from not from the floor, but from they have a sill, but they get to the top or to the beam system. Let me see. There's another picture. Well, then we have these windows. Yeah. So the windows, we have a sill here. It can be like 3 feet, something like that. And then this window goes up to the roof. In this case, we have the windows like that because the roof is tilted. But in this case, it goes up to that beam. Well, it doesn't get up to the beam system, but it goes, yeah, definitely they are bigger than those. So those windows are good for this facade. And we do have okay, yeah. So here we have these booths. So we have a square window there. This is what we have done. But the windows of the main space, yeah, they have a sill, and then they get almost to the to that roof. Okay, so let's do that. This window is too small, so we have to edit type. We have to duplicate, and this is 7. The height is 7.3. Okay, so let's make it 10 times 7.3. No, 7 foot and 3 inches. Oh, now I have to. So the height is going to be 10 feet. Okay. Yeah. So now I have to change those. So this is the window that we have to use in this elevation, and this is the window that we're using on that elevation. So there are 2 different windows here. Remember, if you go to level 0, remember that we had the structural element. So this is the structure. Okay. And then we created the wall. This is the wall. And then we, here, when we don't have windows, we can see that there's a wall. and then the windows are there. Okay, so if we want to insert another window, we can copy the window there, and now it's not a wall anymore. But remember that we cannot place a window just between two columns. We need to create a wall, and then we need to place a window. The same thing we did here. Okay, so this is the wall, and this is the window here. The internal walls can be the same as this one, and then we create here this wood. Where is it? Yeah. We have this element here. So you have to continue, you have to create all the windows, and it's just a question of extending this wall and then copying windows. Once you have the right dimension of the window, you only have to copy this many times. I don't know how many windows are, a lot. Okay, so this is the first thing. The second thing, as you can see, I copied this structure at on this side, and then there's a wall inside that structure. Okay, we look at the elevations. Here we have like a gallery, and this is the gallery that we're going to do using this massing and modeling. So we're going to insert this here. But in this facade, it's opaque. If we look at the, yeah, so this is the gallery, and then the other one. Yeah, the other one is like this. I think it's better. I think I have improved the original project because here they don't show the truss, but I think that looking at the truss is it's even better. It's more appealing. Okay, so we have an opaque wall here, but at least we're showing the truss. Yeah, so whatever. But yeah, so here, this is the truss, and then I placed the wall here, just behind the truss, because I wanted to show it. I don't mind. So you can hide the truss by placing the wall here, up to you. But there's a detail that, well, so adding small details, I think add quality to the project itself. You remember that when we first analyzed the building, there was, yeah, this is it. So you see that the truss, the wood truss, is not touching the ground. So we have this element, this transition. It's made of concrete. Yeah. So this one here, it looks like it's concrete, and the truss is not touching this floor. Okay. So this is an option, but if you want to do it, if you want to spend a few minutes of your valuable time doing this, I can show you how to do it. Okay, so I have done it here. So I have created this element, and then the wooden elements are not touching this. I'm going to work with realistic, and I'm going to. Okay, so how can we do it here? This is a connection between the vertical elements and the diagonal elements. So instead of using the coping, I can want to make it. There you go. So now these three elements are not touching each other. And now I can create this element here. It's not going to be the same because the distances, the spans are different, but I can use the component, model in place. Let me use a wall. And now what is that grid? I think it's grid J. I don't, if I remember well. Yep. And now we have to use extrusion, and we only have to create a shape that okay, we have this shape, and now we have to place it not here. There you go. Okay, so now we have this and that, and we can even change the material. If you select this and you change the material, we can make it of concrete. Concrete, precast. And now if we are using the realistic, we see that this is made of concrete. Okay, so if we want to make it, the problem is that you cannot copy this. You have to do this every time you have these three elements connecting on the same point. You have to do it. Okay, so it takes a little time, and I don't know if it's worth it or not. What I think it's worth changing is the texture. I don't know if you can do that, but I'm not happy with the default textures that we have in Revit. Well, it's not the texture, it's the way they tile this texture. As you can see, we have the concrete here. If we zoom in, we can see that it's concrete, but there is a pattern, and this pattern is repeated. And when we repeat the pattern, it's not natural. So things are not like this in the real world. Can we solve it? I think so. If we select the wall, we edit type, this is a retaining wall. So here the material is cast in place concrete. Okay, if we go to appearance, here we have the texture, okay, and this is concrete, and the material is not bad. I mean, it looks like concrete, it's good. But if you double click here, you see that the scale, the sample size is 1 foot and 9 inches. So that means that we have squares of 1 foot and 9 inches, well, rectangles. This is 1 foot 9, this is 1 foot 3. And then we repeat this time and time again. Let's increase this. Let's make it 10 feet by 10 feet. Done. Apply. And see what happens. Well, it's better. Okay, so at least there's a pattern. You can see that we have these lines here, but at least it's not as, it's better. Okay, so be careful with these realistic materials or this realistic display option, because if textures are not well, well, if we have this pattern that is repeated many times, it looks like ugly. Okay, so take your time to at least increase the size of the texture, and you won't have this this issue of repeating material. So I think that looks better. Okay, so here we have here we don't have this issue because when we have a weird shape, we don't see the pattern. The problem is that we have a long wall like this one. We see that the pattern is repeated many times. With weird shapes like this, it doesn't matter. Okay, we're done. We have done this. Okay, now I want to open the skylight. So let's work with the skylight. And what can we do now? Well, first, take a look at the original skylight. Let's see if there's a picture. Yeah. So there are pictures here. So the skylight is like this shape. It's bigger here, close to the roof, and it's smaller there. So it's not a rectangle. It's what is this? It's like a pyramid. Okay. What you call pirámide truncada. Truncated pyramid. I don't like this. Okay, but yeah. Yeah, we have this this kind of shape. So let's do it. So first we have to open the beam system, because if you remember, if we apply a kind of transparency, okay, so we have this beam system, and we either place the skylight between two beams, but if this is too small and the distance between two beams, I think it's too small, then we have to create, yeah, I think we have 1, 2, 3, 4. Okay, so let's use beam number 1 and number 4, and we have to open these two beams here. How can we do that? We have to select the beam system. So if we filter, we select the structural beam system and apply. Now we can edit boundary. And by editing boundary, we can edit boundary, but we also can include openings here. So imagine that we want a skylight between these two beams. Okay. So we have opened this beam system here. And here we are going to place the skylight. And how can we do it? How can we create a pyramid? We cannot use the walls, so I will use the massing and side option. But before using the massing and side, I need to prepare what we are doing. So let's work to the south elevation. Okay, in the south elevation, yeah, this is the shape. So let's see, let's do this. I'm going to use this level 33, okay, because it's almost at the top of this one. And then I'm going to use this tilted. Okay, we have this slope 1 reference plane. You remember that we created this plane, this reference plane last time. So I'm going to use the slope 1 reference plane, and I'm going to use the level 33. So now the 3D, I want to create massing and side. in place mass. I want to set this plane on slope 1, and I want to use this option, draw and work plane, because if you have snap settings, maybe you are not working on that plane. But if you select this draw and work plane, you make sure that we are working on this reference plane, slope 1. Okay, so select this option, and now we have to why? No, this is not reference plane slope 1. This one, yeah. Here. Okay, so first we have created this square here. Now we have to move to level 33. So we have to set level 33. Where is it? Well, let's say level 52, see what happens. And now I'm going to create another shape, another rectangle here. Now, if I select this point or this shape and that shape, and I create a solid form and finish mass, yeah, I think with the transparency, it's going crazy. Okay. We do have this nice, well, it doesn't look like a skylight, it looks like a chimney. But anyway, it's, I don't know why, because on this south elevation, we do have this level 33. Okay, it's in place. But you have to do the same, but instead of doing it with level 52, you have to figure out how to do it with level 33. I don't know what's wrong, but that's the idea. And now we only have to work with roofs and walls. We can go to massing and site, wall by face. I can use my wall because we need thermal insulation here, and then we can select these faces. And we have a wall. And now we need a roof. Roof, sorry, roof, select, create roof. Okay, so now we have a roof here. And on that roof, we can insert architecture, window, we can insert the skylight. We don't have skylights here, so we have to insert family, windows, and yeah, we can use this one, skylight flat. Select the first, and now we can place a skylight here. The thing is that we need to adjust the size of this skylight to the size of this rectangle. But the thing is that if we want to open windows, it can be either a wall window or a skylight. We need a host, and in this case, we need a roof for the skylight. So if we're working with the mass, it doesn't work. We have to turn this mass into walls and roofs. And now I can filter, and I can delete the mass. And now I have only walls and roofs. Okay, that's the way to create skylights. It's not the right shape. It has to be something like this. Okay? But this is the way we have to create skylights. Okay, so what's next? I showed you how to do this element here, how to create the skylight. And, oh, yeah, I have to show you how to do this with the massing inside using voids. Yeah, I want to show you how to create walls like this. Just to show this example, we're not to insert it here because I think it's confusing now. So first we're going to gain confidence by doing this out of the drawing itself. And then we will try to create it here because last week we did it, but I wasn't happy about this. So we have to make it better because the distance wasn't the right distance. And well, I'm going to try something weird here. So first we are on level 0. We're going to work here, and we're going to work with massing inside in place. And I want to set this on level 0, and I'm going to create a rectangle, let's say 12 feet by a foot. There you go. Now on the 3D view, this, why don't I see this? Oh, because I'm out of the, yeah, probably I'm out of the section box, so that's why I can't see this. I'm going to I create the solid form. No, it doesn't work. Why? I was out of this box. I think now it will work. Okay, massing inside, in place, set to level 0, create a rectangle, create solid form. Okay, So now we have a solid form. And now we have to work with voids. So let's go back to level 0. And I'm going to create a void. Well, first I'm going to create a line. And the line is going to be here. And this is 6 inches. Okay. Now I select this on the 3D view. I want to create a void form. And I go all the way up here. So now I have created a void. If I go to level 0 again, I see, well, I don't see the void, but it's there. And if I create this window, you see that I select the void form. Okay. If I select the void form, I select the void and the solid. And now I want to deselect the solid form. And now I want to copy this. So I want to copy this. If it's 6 inches, now it's 1 foot. There you go. And I want to copy it again. A foot. And again. Can I copy more than one? Probably I will. So I'm going to select this. And I don't want to select the solid form. I don't want to select the first one. And now I can copy. No. Okay, I'm going to go one by one. Go. And now we can finish the mass. Okay, so now we have this effect. If we cast shadows, see. Well, that's interesting. This one doesn't cast shadow. It's not because it's on fire or something like that. It's because it's still a mass. Okay, so I have assigned a material to this one, but this is still a mass. And when we have masses, it doesn't cast shadows. How can we define a mass here? So I have to go to massing and site again. I have to go to walls. And now I have to select, I think I created a wall with an inch here. I'm going to edit this type and I'm going to duplicate. And I'm going to create a 1/2 inch wall. And the structure, I don't want finish, so delete. And I just want this soft lumber and I want 1/2 inch. Okay, so now I select this face and now I do have a wall and now it's casting shadows, see? And now I can get rid of the mass. If I select this, filter, I delete the mask, and I've got this now. Okay, I'm going to do it again, but I want to do this. I want to create like a wall using solid and void forms, and I want this kind of overlapping. Okay, so I'm going to use the same mask, and then I'm going to apply wall to two faces, the inner and the outer face. Okay, so let's try to do this. We are going to start with the same in place mask. I'm going to create 12 foot by 1 foot. Mask here. Now I want to select this. I'm going to create a solid form, and I want to move it up. Now on level 0, I want to from this point here, let's say 1.2, 6 inches. Okay. Now on the 3D, I want to select this, and I want to create a void. And now I go down. Okay, and I have this. But if I select this now, and I deselect this one, and I copy, I want to go a foot, and another foot. Okay. Now I want to move or want to copy the void that here. I can create another void, or I can copy this one. What shall I do? Let's copy the original one. Copy this void here. Constraint. This is what I want. No. Select this one. Nope, this is not. Copy. This one here. And now I can copy all these. There we go. Okay, I finished that mask, and now I want to apply the wall to this face and to that face. And now I delete the mask. Okay. Why am I doing this? Well, that would be enough. Okay, so if you do this kind of wall, that would be enough. But if you look at the detail, you will realize that we have this double, so we have this, the inner face and the outer face here. So we have two of them. And well, just splitting hairs, we can do this. Okay, so because you see that we have two of them, one and two. There is always something here in the middle. There's a beam here and there's another beam here connecting these two elements. So we can do that by going to level 0. And we can always go to architecture, component, model in place, wall, extrusion. Okay, so we can have a beam like this. So we will have this one here. Okay, now the challenge is to do the same thing we have done here with this shape. And well, this is challenging because we have to create a mass with this shape, and then we have to create the voids. So let's try to do it. First, I need to know what reference plane. Yeah, remember that I created this reference plane here, louvers. Okay, so I'm going to work with this reference plane. And let's see, we have 10 minutes ahead of us, so I will keep on doing this. And let's see if I have time to finalize it. So first, we're going to go massing and site, in place mass. Okay, we have to set the plane on these louvers. Well, I think Revit is going crazy again. Set reference plane. Well, sometimes you see the blinking. Now you don't see that. It only happens in my computer. But let's draw work plane. Now I have to select this. I have to create a solid form. The solid form in this direction. Okay. Now level 10. Now I have to create a void. On level 10. I have to select it. And now I can copy 2 feet away. To nice, finish mask, and create wall in this phase. can delete the mask. Oh. Well, you can do that. It's not mandatory, but I think those kind of small details add quality to the, it's like creating all these beam systems and this. And you can take nice screenshots here with these louvers, with these lights and or shade, and so that's better. And just to finalize this, we can go to level 10 and we can create the beam there. I'm going to hide this because it might be confusing. But I have hidden many things. Level 20. Oh, it's on level 12. I don't know. I've lost the grid in which I have created this. But the only thing that's left here is to create like a beam just between these two layers, the inner and the outer layer. So we would be able to create a wall somewhere here. So we can go to architecture, component, model in place, wall. Extrusion. Okay, so now we have this element there. Okay, just to summarize what we have done today, we have done this crazy wall with void forms using the massing inside. Well, we have done it because I like it, and it's something similar that the thing that they have done here, but I think it's appealing. Then we have created a skylight with this shape. It's not the right shape, so make sure that you abide by the height, especially the height of this. But I wanted to show you how to create openings on beam systems. Okay, so you can select the beam system, and then you can edit boundary. And editing the boundary, you can create an opening here for the skylight. And we started by well, creating this detail, this transition between the slab and the wood structure. So we would need like something like this made of concrete. Oh, and we started by defining the two different windows. We have this window here, this elevation, and we have a different window here on that elevation.